For this new example, we have systolic blood pressure of women with normal blood pressure distributes normally and has a mean of 106.3 and standard deviation of 8.9. If a woman with normal blood pressure is chosen at random, what's the probability she'll have systolic blood pressure lower than 104? Again, this is not absolutely necessary to do, but a picture can help you visualize what's going on. So the blood pressure distributes normally, so we've got this bell curve, and we have a mean of 106.3 and a standard deviation of 8.9, which would put us right here at the inflection point at a value of 97.4. If you take 106.3 and subtract 8.9, that gives you the 97.4. So we are dealing with what's the likelihood that her systolic blood pressure is below 104. So 104 is somewhere right in here. We want to know what's the likelihood that her blood pressure is lower than 104. So we need to know this area over here, the area to the left of this point right here. Well, we simply need to go through the strategy that we discussed in the previous problem. We take our raw data values. These are raw data values here. These are the actual systolic blood pressures. We need to convert them to the corresponding z-score, and then we use the standard normal distribution table to find the area or the probability that we need. So first, let's do the conversion to a z-score. So we've got z equals, the raw score is 104, minus the mean is 106.3, divided by the standard deviation is 8.9. And on the top here, we get negative 2.3 divided by 8.9. And remember, our standard normal distribution has the z-scores rounded to the 100th position. Doing this division, you get negative 0.26. If you now look at the standard normal distribution table, the area to the left of a z-score of negative 0.26 is 0.3974. And recall, with our picture, we know we want the area to the left. So this is our probability. We do not need to do any sort of additional computation. So the likelihood she will have a blood pressure lower than 104 is 39.74%. We've done a problem where we found the area to the right, we found the area to the left. Now, let's do a problem where we need to find the area in between. The length of human pregnancy in days is normally distributed with a mean of 272 days and a standard deviation of 9 days. If a newly pregnant woman is chosen at random, what's the chance she will give birth between 260 and 275 days? And just to illustrate that technically a graph is not necessary, we're going to do this without drawing a graph. We need to find the area between these 2 points. So first, these are raw data values. We've got x equals 260, and we've got x equals 275. According to our strategy, we're going to need to convert those raw data values to z-scores. We'll do that first. So we have 2 z-scores to compute here. So we've got z equals 260 minus the mean, which is 272, divided by the standard deviation, which is 9. And here we get negative 12 divided by 9 is approximately negative 1.33. Then the other raw data value has a z-score of the raw data value 275 minus the mean, which is 272, divided by the standard deviation, which is 9. This gives us 3 over 9, and 3/9 is approximately equal to 0.33. So we need to find the area under the standard normal distribution curve between this point, z-score, and this z-score. And to do that, we get the area to the left of this one and subtract the area to the left of this one. And if you do that, the area you get to the left of the z-score 0.33 is 0.6293. The area to the left of the z-score negative 1.33 is 0.0918. And then if we take the difference of these two, we get 0.5375. So if you chose a newly pregnant woman at random, the likelihood that she will give birth between 260 and 275 days from inception is 53.75% chance.